Welcome to the deep dive. Our mission today, well, it's pretty straightforward. We're aiming to give you the ultimate shortcut to mastering hybrid IT. We've got a whole stack of real world scenarios here, 52 of them, actually, that lay out exactly how you can manage those, complex setups. I'm talking about the ones that bridge your physical servers, the ones sitting in your own data center with your Azure cloud resources. And we'll be looking at how PowerShell, Azure Automation, and Azure Arc all kind of work together to make that happen. Automation isn't just a nice to have anymore, is it? It feels absolutely essential these days. But anyone who's tried managing, say, a Windows server tucked away somewhere using cloud-only tools knows bridging that gap. It gets tricky, fast,
Oh,
securely and consistently. That's the challenge.
that really is the core problem, isn't it?
Yeah.
And these tools, PowerShell, Automation, Arc, they are basically the foundation for building that operational resilience. We're after consistency, security, scalability, and the architecture holding it all together is the hybrid worker group. Think of it like a secure agent, right? A local execution engine that lets Azure run your scripts directly on your own machines. The whole point of these solutions we looked at is moving away from those manual, often brittle tasks towards, well, robust automated workflows.
Okay, yeah, let's unpack this. So starting right at the beginning, how do we actually connect the physical stuff to the virtual world?
Right. The very first hurdle is just getting visibility, getting those on-prem Windows servers registered so Azure can even see them. So the step one, building that bridge, it involves using PowerShell typically to install the Azure Arc Agent onto those servers. Once they're registered, Azure sees them, can monitor them, and crucially can start sending commands.
Okay, so ArcAgent installed, the server shows up in Azure, but how does the command, like the actual script execution, get pushed down from Azure Automation to that specific machine?
That's where the hybrid worker group comes in. Inside your Azure Automation account, you define this group, and then you onboard those servers, the ones you just enabled with Arc, into that group. So now when you write a runbook in Azure, maybe a weekly cleanup script or something, you schedule it, but you target that group. The script itself lives securely up in Azure, but the hybrid worker component makes sure it actually runs locally, right there on the server using its local access.
That makes perfect sense for, modern servers that can handle the ArcAgent. But what about the older ones, the legacy systems? Maybe they can't even run the agent. Is automation just off the table then?
No, not necessarily. It's a common problem. If a server just won't onboard directly with Arc, the workaround is to use a hybrid worker that's on a machine within the same network segment. So a machine that can talk to those legacy servers. That worker machine basically becomes your secure relay point, your execution jump box. It runs the runbook from Azure and then communicates locally with those older systems.
Okay, it's a workaround, but doesn't that kind of introduce its own potential point of failure? Now you've got this extra worker machine you need to maintain just to talk to the old stuff.
Well, yes, it does add a component to manage, but it's a controlled complexity. And it's generally much better, much more secure than trying to run scripts directly on those old boxes insecurely. And speaking of older systems, migrating existing task scheduler scripts. That's another common challenge the source has highlighted. The advice there is really about meticulous planning. You absolutely have to inventory every trigger, every dependency the script has. And crucially, you need to parameterize those scripts before moving them.
Parameterize, so making them flexible, right? So they're not hard-coded with specific server names or file paths.
Exactly. You make them adaptable. Then you import these flexible scripts as runbooks into Azure Automation. Carefully recreate all the schedules and triggers you inventoried. And only then, once you've tested it, do you disable and retire those old, often fragile task scheduler tasks. It's a proper migration process, not just a lift and shift.
Right. Okay, so we've connected everything, modern or legacy. Now we need to move beyond just connection to actually controlling things, enforcing configuration, keeping secrets safe. If there's one thing that constantly trips up IT teams, I swear it's configuration drift. You set something up perfectly, turn around, and it's changed.
Configuration drift. Yeah, that's really where Azure Automation shines, specifically using PowerShell Desired State Configuration, or DSC. The beauty of DSC is instead of writing scripts to fix things, you declare the ideal state, your baseline. This could be, specific registry keys must exist, certain services must be running, particular firewall rules need to be in place,
Right.
stuff like that.
So the system itself watches for changes. Like if some engineer manually tweaks a firewall rule on a server, DSC can just snap it back.
Pretty much, yeah. You monitor compliance against that declared state constantly. You can get alerts if a server drifts. And you can configure it to automatically remediate, often in what's called pull mode, where the server checks in periodically with Azure Automation and pulls down its required configuration. But, this is important, you absolutely need process around this. Strict versioning for your DSC configurations is key, and you must test every configuration change thoroughly in a dev or test environment before rolling it out to production. Can't stress that enough.
Okay, versioning and testing, got it. That leads us straight into security. These scripts running via hybrid workers on-prem often need credentials, sometimes highly sensitive ones, to talk to databases or local services. How do we handle that without, pasting passwords into scripts?
Yeah, that's a huge no-no. It's
Yeah.
not negotiable, really. The absolute #1 recommendation, whenever possible, is to prefer managed identities, especially for authenticating to other Azure resources. This is so key because managed identities mean the runbook can talk to things like Azure Storage or Azure SQL without any credentials embedded in the script at all. Azure handles the authentication token exchange behind the scenes.
Wait, why prefer them? Why not just always use something secure like Azure Key Vault to store the secrets and have the runbook pull them when needed?
Because even with Key Vault, which is definitely the next best option, you still have a secret lifecycle to manage. You have to generate the secret, store it, worry about rotation, grant access. Managed identities, when they apply, are tied directly to the identity of the automation job or the hybrid worker itself. Azure manages the underlying credentials and rotation. It just eliminates that whole category of credential handling hassle for Azure to Azure communication. Now, if you absolutely must store a credential, like for an old on-prem service account that doesn't understand Azure AD authentication, then yes, you use Azure Automation credentials or Azure Key Vault. If you go the Key Vault route, you have to explicitly grant the hybrid worker machine's identity access to the specific secret in Key Vault. And that access must, absolutely must, follow the principle of least privilege. Only access to the secrets it strictly needs, nothing more.
And the sources even mention using automation to manage its own security, like
Yeah.
automatically rotating passwords for services the automation relies on.
Exactly. Think about something like an Azure SQL admin password that maybe some runbook needs. You shouldn't rotate that manually. You should have another scheduled runbook whose sole job is to generate a new, complex password, securely update the secret in Key Vault, maybe update the connection string in the application's configuration if needed, and crucially, log the fact that the old secret was revoked. So automation essentially manages its own secrets lifecycle. No humans touching production passwords.
Okay, let's shift gears. Let's get into the day-to-day stuff, the operational grind. And nothing causes more headaches or potential outages than patching, right?
Patching is such a classic automation use case. Tools like Azure Update Manager or maintenance configurations handle the scheduling and deployment. That's great. But the real key, the differentiator highlighted in these scenarios, is using robust prescripts and postscripts alongside the patching itself.
Okay, give me a concrete example. What would go into a typical prescript before patching starts?
All right, so a good prescript would first maybe query and record the status of critical application services running on that server. Then it would gracefully stop any non-essential services that might interfere with the patch installation, or services you know are sensitive to reboots, like maybe a specific application tier or a database service if it's safe to do so. This just prevents the patch installer from failing because a file is locked, or worse, crashing the service mid-update. Then the postscript does the reverse. It restarts those services you stopped, and maybe even runs a quick health check, like hitting a web endpoint or checking a service status to verify the application actually came back online properly after the reboot.
That makes sense, preventing the patch from causing the outage. But what about the political side? Those critical systems that absolutely cannot be rebooted during business hours. How does automation handle those exceptions?
Yeah, managing exceptions is crucial. You can use Azure features like resource tags, maybe tag servers with patchwindow.weekend or something. Or you can have specific schedules within Update Manager or maintenance configurations just for those groups. The automation logic, perhaps in the scheduling or even a prescript, checks for these tags or schedules and automatically defers the patching operation until the approved blackout window is over. Keeps things compliant without disrupting the business.
Okay, let's switch from patching to being more proactive. Like if we're monitoring a server using Azure Monitor and we see, I don't know, a crazy CPU spike, can automation step in and fix it before a user even notices?
Yes, that's the goal of self-healing automation. It starts with monitoring, exactly like you said. Azure Monitor or Log Analytics collects performance counters like CPU utilization from your Arc-enabled machines. Then you create an alert rule. If CP goes above, say, 90% for 5 minutes, that rule triggers an action group. And that action group is configured to do one specific thing: trigger an Azure Automation runbook. That runbook then gets targeted at the hybrid worker on the affected machine. It runs locally, maybe runs get processed to see what's hogging the CPU, and based on the logic you built into it, it could restart the specific problematic service.
So the automation finds and potentially fixes the problem. But what happens if the automation itself breaks? Say a runbook just fails halfway through because it needs a PowerShell module that isn't there.
Ah, the missing module problem. Yeah, that's super common, especially in hybrid setups. Fixing it requires coordinating both sides, the cloud and the on-prem worker. First, you have to actually install or update the required PowerShell module locally on the hybrid worker machine itself. The machine doing the work needs the tools. Second, you also need to make sure that same module, or at least its metadata, is imported into the Azure Automation account so the automation service knows it's a dependency. And third, you really have to validate versions. Make sure the module version on the worker is compatible with the version expected by the script, and also watch out for PowerShell 5.1 versus PowerShell 7.x compatibility issues.
Right, and that brings up PowerShell 7 support. Why is it becoming so important to make sure our hybrid workers are running PowerShell 7?
Well, PowerShell 7, or PS7 as people call it, it just offers some really significant advantages. Better performance, much better cross-platform support if you have Linux workers too, and importantly, newer syntax and CMDlets that modern scripts often rely on. Things like for each object parallel for speeding things up, which we'll probably get to. So if your runbooks need those modern features, you first have to check that your Azure region supports PS7 runbooks, and then you absolutely need to ensure your hybrid worker machines actually have PS7 installed and configured. Otherwise, those advanced scripts just won't run. You'll be stuck with older capabilities. And, if we connect this to the bigger picture, achieving real operational excellence isn't just about fixing things when they break. It's about doing it fast, doing it reliably, and doing it at scale.
Okay, let's talk speed then. Say I have a runbook that takes ages, maybe 10 minutes, because it's contacting dozens of servers one by one. How do we slash that time?
The biggest win here is almost always parallelization. You have got to stop thinking sequentially for bulk operations. If you're using PowerShell 7, leverage features like for each object parallel. Or even in older PowerShell, you can use background jobs or thread jobs, though they can be a bit more complex to manage. But the point is, instead of doing task A on server 1, waiting, then task A on server 2, waiting.
Yeah.
You fire off task A on all servers simultaneously. It's a massive time saver for any kind of fleet-wide operation.
Okay, parallelization is key. What else helps speed things up? Any other tricks?
Yeah, a few other things. Think about batching. Instead of making 100 tiny remote calls, can you make one larger call that does the work in bulk? Reduces network overhead. Also, run the work as close to the target as possible. That's the benefit of hybrid workers. The script execution is local, minimizing latency compared to running everything from Azure. And one subtle thing is module loading, especially with large modules. If your script loads a big module every single time it runs on every single target, that can add up. Avoid repeated loading if possible. Maybe preload modules if the runbook runs frequently to avoid that cold start delay each time.
Makes sense. Okay, speed is one thing, but what about resilience? In the real world, servers aren't always online. Networks glitch. How do you build runbooks that don't just fall over and die when they hit a temporary snag?
Right, the runbook itself needs to be built defensively. It needs robust error handling. That's not optional. This means things like explicitly testing connectivity to a target machine before you try to perform a critical action on it. Use test connection or test WSBin. Catch specific exceptions using try-catch blocks. Don't just have a generic catch-all. Try to handle known recoverable errors differently. And for things like temporary network issues, implement retry logic. But not just simple retries. Use exponential backoff.
Exponential backoff.
Yeah.
Remind me, that's where you wait longer between each retry attempt.
Exactly. So instead of hammering the connection every 5 seconds, you wait 2 seconds, try again, wait 4 seconds, then 8, and so on. You give the network or the target service time to potentially recover.
Sure.
And if, after a few retries, a target is clearly unreachable or an operation fails persistently, the runbook shouldn't just crash. It should log the failure clearly, maybe add it to a list or report, and then continue processing the other targets if possible. Aggregate the failures instead of having one failure halt everything.
Okay, that makes runbooks much more robust. Now, what about scaling the whole operation? Our environment grows, we need more automation capacity, and how do we govern all these runbooks, especially across maybe multiple teams or Azure subscriptions?
Scaling the workers themselves is relatively straightforward. You provision new machines, VMs or physical, install the necessary prerequisites, install the agent, and register them into your hybrid worker group. And of course, you need to monitor the health and load across your worker pool. But for governance, especially across multiple subscriptions or environments. This is where you absolutely must bring in source control, like Git and proper CI/CD pipelines. Seriously, this becomes almost mandatory for consistency and safety at scale. You check your runbook scripts in Git. Use pipelines like Azure DevOps pipelines or GitHub Actions to automatically test the scripts, maybe lint them for style or errors, and then deploy them to your different Azure Automation accounts, dev, test, prod. This gives you version history, peer review through pull requests, and crucially, the ability to easily roll back to a previous known good version if a new deployment causes unexpected problems. Trying to manage dozens or hundreds of runbooks manually across environments is just unsustainable.
Right, source control is key for managing the code. Okay, let's wrap up by focusing on the value proposition. How does all this automation actually save time and, maybe more importantly, save money? Let's hit reporting and cleanup.
Sure. Reporting on compliance is a big one. Instead of someone manually checking patch status every month, you have a scheduled PowerShell runbook. It queries the update assessment data, probably from log analytics, or using the as modules directly. It filters for what matters, say, critical and important updates missing. Then it formats that data into a nice report, maybe HTML, maybe a CSV file, and emails it out or saves it to SharePoint. Audit requirement met, zero manual effort.
And the classic money saver, finding oversized VMs and shrinking them down, VM right-sizing.
Yeah, pure cost optimization, again a scheduled runbook. This one pulls performance metrics CPU, memory utilization from Azure Monitor, maybe over the last 30 days. It identifies VMs that are consistently underutilized, like maybe average CPU below 20%. It can then look up the current VM size, SKU, and potentially propose a smaller, cheaper SKU that still meets the performance needs. And then it can automate the actual resizing. But critically, especially in production, you'd want this to run in a dry run mode first. Generate a report saying, I plan to resize these 10 VMs, saving X dollars per month. Get approval, then run it for real.
Okay, dry runs are crucial. And finally, resource cleanup, getting rid of all that forgotten dev test junk that accumulates costs.
Oh yeah, the digital equivalent of cleaning out the garage. A scheduled runbook lists resource groups. It filters them, maybe by age, well, the 90 days, or by specific tags indicating they're temporary. Very importantly, it must have logic to exclude critical resource groups, probably based on a tag like environment, production, or critical. True. You don't want to accidentally delete production. Then it might do a check. Are there actually any active resources inside the group? If it's empty or only contains stop VMs, it's a safer candidate for deletion. And then it initiates the deletion. And again, like right-sizing, you absolutely use the last what-if parameter extensively during testing and maybe even for initial production runs to see exactly what would be deleted before you flip the switch. This raises an important question. Looking back at the sheer scope of these 52 scenarios, it's clear that PowerShell, Azure Automation, and Arc aren't just simple scripting tools anymore. They're really the building blocks for implementing deep compliance, robust security posture, and genuine operational resilience across that whole messy hybrid landscape.
Absolutely. I think the key takeaways for you listening have to be understanding the power and, frankly, the necessity of using managed identities for secure authentication wherever possible. Grasping how DSC lets you enforce configuration standards, not just report on drift. And really internalizing that hybrid worker concept, it's the fundamental bridge connecting your Azure control plane to your on-premises execution. So we've spent this time talking about building incredibly powerful, secure automation. But here's the final thought, the thing to really chew on. With all this power, how absolutely critical is it to make sure the automation itself doesn't become the next attack vector? If you're not enforcing rigorous code reviews, demanding code signing for critical scripts, and deploying everything using strict least privilege principles, could your automation accidentally be opening new doors for security vulnerabilities? That discipline might just be the difference between true operational excellence and your next major incident. Something to think about for your next automation project.